Hi everyone, today we're going to be learning about the sign of a function. And this is where we're going to be aiming to figure out how and where a function can change its sign, figure out the points of discontinuities, look at the sign of a function by using a table of signs, solving our polynomial equations and inequations that might have discontinuities. So just as a reminder, we can always move terms in an inequality to move to the left. So you can see this example here. We're going to be doing one like it very soon. But basically what that means is we have every inequation becoming one of these cases. And that's really important for you to remember. So in other words, what we're trying to do when we solve an inequality is figuring out its sign. And figuring out its sign basically means that we're looking for places where there are zeros or discontinuities. Okay, so zeros is kind of like when we factorize and we solve for x, letting something be equal to 0, or in this case, greater than, less than, or greater than or equal to, less than or equal to 0. We talk about continuous and discontinuous functions. So for a function to be continuous, basically when you graph it, you won't need to take your pen off the paper. If you're graphing something and you need to take your pen off the paper, we call that a discontinuous function, and you can read about that here. You can see that this graph here has discontinuities at point C, then there's asymptotes marked, D at E with the open circle and F with the open circle. It has zeros at X is A and B. In other words, that's where the X intercept values are 0. So to determine the sign of a function, what you need to do is make a table of what we call signs, a table of signs, and we test values that dodge around zeros and discontinuities, and that can help us graph or to solve polynomial equations. Key point, which you already know, is that if you're looking for a place of discontinuity, also could be an asymptote, we assume the function is continuous, except where there's an obvious problem. So, for example, where you can't have a 0 on the bottom of a fraction and that sort of thing. So to solve polynomials, we engage in these 4 steps. You have to draw a table of signs, state where the function is positive and negative, solve an inequation if you've got one, and then confirm by sketching. Not always will you need to sketch, but a lot of the time you'll want to. Okay, so to start off with, let's have a look at this problem. Again, these problems are very similar to the ones in your text. I believe they're pretty good examples to start with, so if you get stuck, you can have a look at your text as well. First question, it says draw up a table of signs of this function. And you can see this is probably going to end up being some sort of cubic functions because we've got x times x times x. But a table of signs, what we want to be doing is we want to be thinking about these values here. Okay, so to make a table of signs, you've got an x value, a y value, and you're going to have the sign. And you're just literally creating this table here like this, and you're going to put values in this table. And that's going to help you figure out what's going on. Then you're likely going to want to get your calculator out and then insert values into that. Okay, so when I work this out, and you'll want to double check these yourself, these are some of the values I got, and so I know that's a negative sign, so I'm going to write a negative there. For 1, I got -6, and again, negative sign. When I put 2 in here, because that creates the first one as 0, it's going to make them all 0, which means the sign is also 0, cuts the x-axis there. Similarly for 3, if I put a 3 in there, that will make that a 0. If I put 4 in there, that will make that a 0. If I put 5, that's the next first time I'm not going to get a 0, and this is the first time I get a positive value. And you'll notice that there's some sort of symmetry here as well. So that's kind of parts A and B there, state where it's positive and negative. I'm then asked to solve the inequation. Okay, so if I want to solve this inequation, basically what I'm looking at is if I'm trying to solve this, I want to see when this function is less than 0. In other words, when is it beneath the x-axis? So what I want to think about is basically looking at the signs and looking at my y values. Now I know that it's going to be when x is less than or equal to 2, because at 2 I've got a 0 and then negative sign, so that's when it's going to be less than 0. Or I could also have it when x lies between 3 and 4. Because if you have a look at our results here, between 3 and 4, they're also 0, right? So that's less than or equal to 0. So if I'm going to write that in interval notation, I could have that as negative infinity to 2 with a square bracket. And so I'm putting my union in, and between 3 and 4. And they can be equal to those. Okay. If I then want to sketch the function, I would need to then plot points at 2, 3, and 4. I know my y-intercept is at negative 24, because for y-intercepts I let x be 0, and you'd have to just mark this on your graph. Here's what it looks like. I've quickly done it on decimals, but you've got to imagine this line here would continue to go down and cut the y-axis all the way down here at negative 24. Okay, so that's what you've got to imagine. And you can see there how the signs work. So when we graph it, we use our table of signs. So if I'm looking at 0, then I know as 0 my graph's negative, so it's going down here like this. And I've got a negative y value. At 1, it's negative 6, so I can plot that point. At 1, I'm at negative 6, there it is there. At 2, I'm at 0. At 3, I'm at 0, so that means it goes up. I don't really need to know that point. At 4, I'm at 0, and then it's continuing to go up. Okay, so that's how you do in your graph. The next one wants us to solve this inequality and then confirm this answer by drawing a graph. Okay, so again, my first step here would be to get everything onto the left-hand side. So what I want to do is I want to go x cubed minus x squared plus x minus 1 is less than or equal to 0. That's my first step. Then what I want to do is factorize by grouping in pairs. So I'm going to take out x squared and go, that's x minus 1 plus, and I've got x minus 1 here. And that's going to be less than or equal to 0. Okay, so at this point I can then factorize again because I've got a common bracket there. So I've got a little 1 at the front here. So I'm going to have in one bracket x squared plus 1 and in another bracket x minus 1 is less than or equal to 0. And that's going to help me know where to solve things. I can then create a table of signs. If I create a table of signs, I'm doing this thing again. And this time I'm going to pick values from negative 2 to 2. Again, we can choose these values unless the question asks. But when I did this one, I got in here negative 15. Then I got negative 4, negative 1. I got 0 and I got 5. And here are what my signs look like. So that's going to help inform me of my graph. In other words, when I think about it up here, x can basically be less than or equal to 1. Okay, because they want me to know when is this graph below 0. When I graph it on decimals, so if you graph it by plotting points, here's what it looks like. When is this graph beneath 0? Well, it's everything to the left of this minus 1 point. So in other words, it's everything to the left of here. If this is where minus 1 is, it's everything this way of that. So we write that as x is less than or equal to 1. If I want to write that in interval notation, I write that as negative infinity to 1 inclusive can be equal. Okay. Okay, then we come to solving equations with discontinuities. You can have a little read of this blurb here. We're not going to look at really sketching these yet, although I've put the decimal graphs in there. All we want to do is examine signs. Okay, so if we're thinking about examining signs, what you want to do is you literally want to make a table. Again, just like we were doing. So you're going to put X, Y, and your sign in. And you just use your you can just sit there with your calculator and type in the values. Well, you can do it in your head, really. But I just went from 0 to 5 for these. Again, there's similar examples in your book, but when I subbed in, I got 2/3 for this one. I got a half, then 0. This is where the asymptote is because you can't have a 3 on the bottom there. It creates a 0. For the 4, I've got a 2. For the 5, I've got a 3 on 2. And then you put your signs in there. Okay, so just remember this doesn't mean negative, it means there's an asymptote there. So this one basically tells you that you've got a 0 at x equals 2. You've got a discontinuity at x is 3, because that's where your asymptote was. When you plugged it in, you can't have a 0 on the bottom, and that gives a 0 on the bottom. Okay, so that's pretty much all you have to do for that. There's no need to graph it in year 11. With this next one here, you're going to do a similar thing. It asks you to examine the sign, but the cool thing about this one is that you'll notice that because there's always a plus x squared here, it's always going to be positive. So we can just literally write that. You don't actually have to do a table of signs here. You just can write that function is always positive. Since 2 plus x squared will always be at least 2. Okay, so you don't need a table for that one. For number 3, just as a reminder, we've got 2 ways now that we've learned to solve an equation with the pronumerator and the denominator. One is by a table of signs, and one is multiplying out by the square of a sign. So the first one here, I'm going to run out of time in my video, but what you have to do just to get you started, and I want you to have a go at this, is just push everything over onto the left-hand side. So you're going to get 4 on x plus 1 minus x is less than or equal to 0. Then I want you to, you can try and factorize that, get a common denominator first. So that's really over 1. So get a common denominator, that'll be equal to 0. Then use your tables of signs, because it asks you to use this method, except you're not going to go x and y because it's an equation. You'll just go x, the left-hand side, and then the sign. So I'll leave you to fill that out and get a common denominator. Fill out your table. That will help you know what's going on. And then that's all they want you to do. And then with the second one, you're going to be using it's the same question, but you're going to be using the square of the denominator. So this one, you don't have to get everything onto the left-hand side. What you want to do is you want to multiply both sides by x plus 1 squared. Okay, so you're going to go this side multiplied by x plus 1 all squared, and this side multiplied by x plus 1 all squared. Work that out, move it onto the left, and then see what you end up with. You may also want to graph it. Okay, so have a go at those. Remember, you can use the examples in your text in this section, sign of a function, to help you. Write a summary of what you've learned, anything you're still curious about, and then I want you to have a go at some questions from 5B. Thanks everyone, I look forward to seeing you soon.